Welcome to lecture 31. So today we'll go for something new. It is on the chapter 17. So basically today we learn the topic about some system of centralized system. What is a centralized system? The CPU and the computer or the laptop we are using in our day-to-day life, it is a centralized system. In a centralized system, there is some parts of computer and there are single user system. Basically the things are basically all the equipments, all the parts are coming through a single system, a single hardware parts, and there one user is using the system at a time. So multiple user can be use this system through different connection and connectivity, but not at the same time they can use the system through but it depends on different operating system. As Windows operating system, it cannot give the access to use multiple user at a time, but if you use the Linux and other Unix operating system, it give the flexibility of using multiple user to work in a system in the same time. So if we look the architecture of a centralized computer system, so it having some CPU, it having some disk and disk controller. If you have multiple disk, you need to have some disk controller, some USB controller for keyboard, mouse, printer, and some graphics adapter. It might be a built-in GPU, or it might have a extra port or extra card for the monitoring the devices and monitor devices, and also having some memory, that is basically the RAM. So this is a centralized computer system. Now if we look for a client server system, in a client server system, basically there may be multiple clients can be connected through a server by some networks. This network can be a intranet, can be an internet over the network. So client may have a computer system which is a centralized system, but the server it having a powerful servicing system and powerful architecture which can allow multiple clients at a time to processing the data from the server. So client may be send different types of request in the server or same type of request, and the server is processing this data and then it sends back the result to the client. So this is the client server module. So in the client server module, that is basically having two parts. One is the front end and another one is the back end. So in the front end, we can say that in the front end, that is basically some forms, some graphical user interface, which is basically we say the GUI, and the back end, which is basically used for the accessing the structures and query and evaluation and optimization, these sort of things. So in this system, it having the feasibility of different type of database, suppose like MySQL, SQL, and these sort of things, and this system having different type of protocols. So these protocols for interacting from the back end to the front end is called the API. Suppose like you were doing some SQL, so you need the SQL API, that is the application program interface. It is a protocol. So whatever it done the SQL engine in the back end, so the form generation and the data analysis and other things are having the front end. So in this front end and back end having a connectivity, this connectivity is called the API. So you are using different type of Android devices, it also may have different type of API. Suppose like if a Android device need to evaluate or need to track down the position of a user, it need to connect it with the GPS devices and GPS track, so it may need to have the GPS API. So this is how the client server module is organized. So client server system is far more better than the centralized system, because a centralized system having a single unit of the database and the sort of system, but in the client server system, the client may connect it with the server with some mobile phone or tablet or computer, but the server system is need to be functional and backend having some costly use, and also it also give the customer experience with the better interface. So and it is also easy to maintenance, because if the server is doing fantastic, then the user having no problem to access all this data. So our next model is the server system architecture. So if we looking for a server system architecture, so there are different type of server, basically two types of server there, that is a transactional server and data servers. So two types of servers is mostly used. Transactional server is basically organized with different type of transaction and their processing system, and it also having some queue management process that many customers can be hit or can be logged in a server at the same time, but all the customers processing cannot be done in the same time, so it need to have some queue management process. And data servers are basically having preserves the data and database oriented things, and these also having to calculate the inventory and these sort of things. So data servers and transactional server, these are two both are installed in a same place, but whereas they are working as a two different engine. So in the transaction server, that is first thing is the query server. It is basically running the query of what you give the what you ask in the interface. Suppose like you want to find out some people or some information of a client, so client sends a request to the server, then the transaction are executed in the server. So client need to give some send some request to the server with some forms, with some icon or with some link, and then transaction are executed in a server. That is, one transaction is happening, so customer is request something with a RPC call, so then the requests are shipped back to the client after the evaluation. So the RPC, that is the remote procedure call mechanism, is happened here. So a call is happened to some API from front end to the back end, and this back end and then calculate the total result, and it making the queries, and the result is then shipped back to the client with the same API. So in nowadays it is very much using the database connectivity, that is API is the ODBC, is a C language application program interface standard from the Microsoft connecting the server. So basically Microsoft SQL Server and Microsoft products and also the C# and these sort of things are working with the ODBC, and JDBC is just is for the Java, and these JDBC is mostly popular because Java programming is nowadays rule the world. So JDBC is totally very much reluctant and working efficient, and these sort of things is working fantastic with the Oracle and Linux environment. So transactional server, so transactions process server, what is basically happening that in my last lecture I have said that whenever a lot of transaction coming at the same time, the computer having some threads, and these threads are not unlimited. There's a limited number of threads for a server, so the server is making some queue, and these multi-threaded servers are processes these requests one by one. After one request is completed, then another request is come. So server process is maintain some queue, but by this time which requests are already come, that are controlled by some lock manager process. Lock manager process is basically whenever a request is came to the server, it is a thread is taken this work to execute, then this request is locked. When the process is locked, when a transaction is locked, the relative account and other things will be locked also. So this will not be finished until it is returned back to the client. So it is totally follow the ACID properties of the transaction. So that is basically the transactions process server works in this fashion. So in a transaction process server, there are other options also and other parts, that is the log writer process, checkpoint process, and process monitoring process. So in the last class we have learned that transaction process monitors. So transaction server also having a utility of processing the monitor process. So and also the checkpoint process, it also check the periodically the performance of the computer and the server level, and also the log writer. So every types of transaction is happening in the server also maintain a log, because without a log you don't know how the transaction are comes and these sort of things. So these things are happening with some log writer process, and also some checking point, and this log writer process is always doing some operation like these sort of things, and these things are maintaining the each of the vital point and access of the user all the time. So this is the whole over the structure of a transaction system. So as we are working in an environment that we have a very less GUI, and we think that we just submit some query or some form, and this is just processed by some database, but that is not, because in backend there are two types of server. One is the data server and one is the transactional server. So is the transaction, whenever a transaction is happening, there is a lot of things are happening in behind. So you have to understand this image, so for long-term understanding. So all the process and these sorts of things are monitored by the process monitor and log manager process, and there is a buffer pool which is basically maintain the query plan cache and log buffer and log table, these sort of things. So this is how the things are happening here. So if we looking for a data server, so in a data server it is basically used in the high speed LANs. Basically if you have some movie server and these sort of things, so these are send some request or some links, and these are shipped back to the as a total data, and these data are functionally sent to the clients by different issues like page shipping and item shipping, all locking and data caching and data lock caching, these sort of things. So what is a page shipping and what is a item shipping? Whenever a total data is sent to a server, suppose like if you send a mail to me with some large PDF, so if I want to download it, it's a item shipping, because the total content is one file. But if I'm going to some torrent server, it is some page shipping, because the file are split in different servers, and each of the part of a file is come to the different PC. So it is a page shipping. So each page is size is fixed. If a movie is 700 MB, so this movie, if the movie is split in 100 parts, so each part is 7 MB. So 7 MB is a page size. So different PC or the client who are seeding the data from different location, the heterogeneous locations, they are basically page out and page pairing the values of the file, and these are having some indexing. That is, if a 7 MB file is split in 100 parts, so each of these having 7 MB, and each of these having some indexing 1 to 100. So if your computer system is receiving one file number 49, then it's having another part from another computer, it is having the another part serial number of 50. So 49 then 50 can maybe come from the another PC, but it also managing the total system by some locking process. So locking process is basically doing the delay and maintaining the delay and other queue management process. So these queue management process are basically maintained by the data caching and lock caching. So data can be cached at client even between the server, and also check the data up to date before it is used. That is one thing. And another thing is the lock caching. Lock caching is basically doing the operation of of lock, and acquire the cache locks is without containing a server. So server is callbacks from the log from the client, and it also receive the conflict logs. So these are the things happening in the transaction across the system. So in a parallel system, there are some factor of throughput and response time. So in a parallel system, the throughput, that is mean the number of tasks that can be completed in a given time, and response time is the amount of time it takes to complete a single task from the time it is submitted. So there are two types of thing. So if the system is going parallel, so throughput is increasing along with the response time, because if you have multiple threads to work, so response time is below than the single core system, and also throughput is more better than the single core system. So this is how the cross gain and multiple parallel system is gain the fine parallelism of the using the transactional and data servers. So there are two types of equation used here for the gaining the throughput and the speed up. So one is the speed up. So a small system is given a time of a small work is given here, and the large system given here. From that the speed up equation is found, and speed up equation is linear. Okay, so speed up equation is linear, and scale up, if we increase the size of the both problems, so we can scale the up the total problem. Suppose like if you think that you submit some problem of 10 problems, and your speed up time to solve this problem you need 30 minutes. So if we now scale up, that is the 10 works is submitted, and for that to compile this work you require 30 minutes. So for one work you require 3 minutes. So if you now scale up it is to the 50 words, so you need to have 150 minutes as a scale up time. But it shows that in the real life that though it is a linear graph, so whenever the speed is going up and the resource is going rises, so the it should be in the linear, because the resource are increasing and the speed should be going up. But at a certain time it is not as like as the linear, it is going as a sublinear graph, because if you give the total resource lots of, suppose a computer required a computer may have 4 GB of RAM, you are giving a speed of this sort of types to execute the job. If you make the resource double as like 8 GB, but that should not give you the double performance. Okay, because some of the memories are occupied by the operating system, some of the memories are occupied by the different other particles. So all of the time you cannot get the exactly dual speed and the linear setup for this. So scale up is also same. So for any scale up the problem size is getting high, so you cannot say the speed up is going as the ratio of the problem size. But so the graph should be like this, is a linear scale up. But as I say earlier in the last slide, that the things are not happening as linear in the real life, so it is making a sublinear scale up, and after the problem size is getting too high it is going to the fall. So speed up is not working with the same ratio for this increasing of the problem size. So that is the thing happening here. So thank you for watching this video.